Hello everyone, this is Dan. I wanted to give you a brief lesson on what's called modeling the Earth's atmosphere. Being it's Earth Week, we want to get a good idea of what is going on, particularly with this thing that we call climate change. To do that, there's some fundamental ideas that I think we need to master. So, very short, brief lesson on this. Key terms: atmosphere, impervious, greenhouse effect, and greenhouse gas. So let's move on, shall we? So what we're going to do now is we're going to model, or draw in this case, what the Earth is like in terms of what's called a greenhouse. So you probably know what a greenhouse is, right? You've seen these glass houses that people love to put plants in and grow things in. Edison actually used to have a pretty big greenhouse program, but that's no longer there. So imagine that it's dead of winter, and there, even believe it or not, even in the wintertime, there is still sunlight. It's not great, but it is there. And that light and heat will enter this greenhouse and it will give energy to these plants to grow. Well, inside this greenhouse, believe it or not, there are some gases that are there, as there always are, and they will trap heat as well, which will keep it warm very much like a blanket. Now, so what? What does this have to do? Well, if we take the Earth and model it after a greenhouse, let's do that. So if I take a little glimpse, imagine we're out in outer space like astronauts looking at the Earth from afar, and then there's this thing, this star in the distance called the sun. And the sun, believe it or not, you know it's crazy, over 1 million planet Earths can fit inside our sun. Crazy. Well, here's the sun, which is always emitting radiation at some point on the Earth. So what happens is sunlight is constantly hitting the Earth in some way. Okay? Like that. Obviously, much like the greenhouse, the Earth will warm. The surface material will warm. That could very well be forests. Imagine that there's forest land there. That could be, okay. Also imagine that there could be oceans, rivers, and lakes. These actually trap heat, and they've got some way of balancing the temperature on the planet, which is roughly, on average, 59 degrees Fahrenheit on average on the planet, which makes it pretty cozy to live here. And there are also environments like where we live often are going to be city-like. And city buildings and driveways and streets act as reflectors very often. We'd say they're very impervious to sunlight, and that might reflect back. However, all these relationships nonetheless keep this Earth at a certain temperature. Now, the other concern we have to do is with this thing called greenhouse gas. So greenhouse gases are really going to be in the lower atmosphere here that are going to generate a way to trap heat. All right, and we're going to look at some of those. The big one here, as we know, is carbon dioxide. But there's some other ones that play out. Believe it or not, even water vapor acts as this, and some other ones. Tomorrow we'll look at what those are like. Nonetheless, what those do is those act much like in the greenhouse before. These are going to act much like a blanket, okay? And what these will do, these can trap heat. The problem is, globally, locally, everywhere, they are on the rise. CO2 is increasing. We'll look at why that is. Methane is also increasing. Water vapor, due to increasing temperature, is increasing. And this thing called CFC is also increasing. So what happens? That creates more of an ability for heat trapping. So this average temperature will and is on the rise. Okay, this is on the rise. And because of that, it's going to have a big impact on this thing that we call the climate. And the climate, or the weather, which is going to be temperature and precipitation patterns over time, are going to be radically modified as a result. Okay, so that's the overall gist of this. Okay, so I'm going to give you some questions to ponder and write about related to this. Please turn them in, and good luck.